Okay, cubic function. So we've got f of x is equal to x into x minus 3 squared, with f dash 1 or f prime 1 and f prime 3 equal to 0. And we have a random point here. Okay, so we're going to get to this at a bit of a later stage. For now, let's just answer the questions. So 8.1, show that f has a point of inflection at x is equal to 2. So point of inflection, do your double derivative, your second derivative, double dash, double prime, 2 primes, KSI and Logan Paul. Okay, no more jokes. Let's do the question. So first things first, we need this in standard form, so let's simplify it. So look, if we were just to expand the brackets, it'll look something like this, and we need to simplify that, okay? So in 8.1, that simplified is going to give us x cubed minus 6x squared plus 9x, and that's f of x. So the first derivative is going to be equal to 1 times 3 is 3, x, 3 minus 1 is 2, negative 6 times 2 is negative 12, x, 2 minus 1 is 1, so we don't need to show it, and the derivative of 9x is just going to be 9. Okay, that's our first derivative. Our second derivative, 3 times 2 is 6, x, 2 minus 1 is 1, the derivative of 12x, well, it's just going to be minus 12, and 9 is a constant. The derivative of a constant is just going to be 0. Okay, so that's our original equation. Yes, that's our first derivative. Yes, and that's our second derivative. Now we equate our second derivative to 0. So 6 minus 12 is equal to 0. Therefore, x is equal to 2. How did we get to? Well, that's going to be 6x is equal to negative 12 on the left-hand side. Take it over to the right-hand side, becomes a positive 12. And that is x equals 12 divided by 6, and that's just going to be 2. So that's how we got it. That's the quick calculation. So that's 8.1 sorted. Easy. Mahala 5 marks. Okay, I'm just going to clean the screen quickly with a bit of jig. Okay, next is question 8.2. So sketch the graph of f, clearly indicating the intercepts with the axes as well as the turning points. So I'm just going to draw the Cartesian plane quickly. That is horrible. That graph is not straight. Okay, I'm going to redraw it. Goon School be making the mistakes. Okay, that's a bit more decent of a Cartesian plane. Just let me do my arrows quickly. So that is our y-axis. That's our horizontal x-axis. Okay. And now let's actually analyze this question. So we need to get our x-intercepts. And look, as you can see, it's already been factorized. So x is going to be equal to 0. So we're definitely going to have an x-intercept there. And x is also equal to 3. So another x-intercept somewhere here. Now, the first derivative, when we sub in x is equal to 1 and x is equal to 3, we get 0. So what does that mean? Like, what is this telling us? We have a first derivative, yes. We're subbing in x, and we're getting a y value of 0. Guys, these are stationary points or turning points. So the graph is going to turn at 1. So 1 is going to be like somewhere there, and 3 is going to be somewhere here. Right? So the graph is going to turn. So the graph is literally going to turn on the x-axis, and we actually call that a repeated factor. We call that a repeated factor when a graph turns on the x-axis. But look, it's also important to note that 1, it's not just our turning point. It's also a random point. So we know that there's going to be y is equal to 4 here on this side. So now we can draw our graph. Remember, it must turn here, and that's an x-intercept. So it's going to look something like this. So yeah, your graph is going to look something like this. And this graph precisely is the reason that Goon School doesn't teach art, visual arts. I'm joking. I'm going to make visual art theory videos. But yeah, Goon School can't draw, hey? Yo, but also they used to like break my confidence down quite a bit in primary school. Like I had this teacher, like Mrs. Jordan, you know, like she never gave me any like words of validation and confidence. And, you know, as a result, my artistic ability went, under the radar. Until I hit grade 9, and I had this an amazing teacher. His name was Mr. Puren, actually. Really amazing guy. Really, he's actually he's passed on now, but amazing guy. He brought the best out of me as an artist. Really nice guy. He was also like the cricket coach and encouraged me to play rugby as well. It was an amazing experience, like having him as my teacher. Absolutely crazy guy. Very eccentric. I mean, he was an art teacher, so what did you expect? And yeah, like when I delivered like my final project in grade 9, he couldn't believe that I actually did it. Like he was like, nah, like you couldn't have done this. And I'm like, yeah, Mr. Pure, like I've got the proof here. This is like, you know, my diary, I'm forgetting what the word is now. Yeah, the word has completely escaped me. But you know, like when you like just take pictures and stuff of an art project and you like document it, and you know, like the reason behind it. It starts with an R. I'm forgetting the word right now, but yeah. What a legend. And I don't know, I just didn't get enough like validation. I guess, when I was in primary school, to like actually be like, yo, I'm a good artist. I'm gonna go out of the box now. I was just kind of like, do my own thing. Like, just don't even try to be creative. Just do what they tell you to, draw these basic things. So yeah, like nurture people. Don't put people down, especially those who aren't good. Perhaps they're not good because, well, they just don't back themselves. They don't believe themselves in themselves. They've never, like had the stepping stones, the opportunities. They haven't been nurtured enough. And yeah, maybe they're actually good at something. Like I remember I took my girlfriend's sister out for bowling on her birthday, and the three of us were playing. So my girlfriend and I, as well as the sister, and we were just cheering the sister on because it was her first time playing bowling, and she was actually pretty good. Like she scored like over 100 on her first time playing 10-pin bowling, and yeah, she was just loving it. She was loving the applause, and she was doing so well, and that was really great. So yeah, just some kind words, it can go a really long way for people. But yeah, Goon School got really deep. Okay, so we've got our origin here. X is equal to 0 is going to be one of the intercepts, so it definitely goes through the origin if it goes through x is equal to 0. We've got our random point, which also doubles as our turning point. We've got our x-intercept at positive 3, which also doubles as a turning point, a stationary point, and it turns on the x-axis. We call that a repeated factor. Okay, and last question, 8.3. For which values of x will y equal negative f of x be concave down? So quite an easy question here. We've calculated our point of inflection. So it's just going to be all the values that are greater than 2. Why is it greater than 2 if it's concave down? Well, if our a value, which we know is positive, the graph for concave down should show x is less than 2. So this is going to be concave down. So concave down, if a is equal to 0, x is going to be less than 2. So quite similarly, if a is going to be less than 0, x will now be greater than 2. So that's how we get our answer. So you're probably wondering, hey, but isn't a positive? Yes, a is positive, my friend. So the answer should have been x is less than 2. But you see there's a reflection here. There is a flexion. It's minus y. So there's going to be a change in our x values for the graph. So instead of it being a positive a, it's going to now change to a negative a because of this negative here. So a is not going to be positive anymore. A is going to be negative. Therefore, the sign flips and x is going to be greater than 2. Nice little tip. Okay, see you guys in the next video. Goon School is depressed now. I'm normally like upbeat and things, but I kind of miss school. Joking. I don't. School was rough. Happy to be done. Okay, cool. See you in the next video.